Determine the values of x on the interval from 0 to 2 pi, where y equals cosine squared of x has a horizontal tangent. Okay, so remember that a horizontal tangent means that the slope of the tangent line at that point is 0. So I'm trying to figure out where is the derivative of this function equal to 0. So let's first find the derivative function, and then I can set that equal to 0. All right, so y equals cosine squared of x. I have a formula for cosine of x, but I don't have one for cosine squared of x. So let's see if there's a way I can write this where I can actually find that derivative. So I can rewrite cosine squared of x as cosine of x times cosine of x. I know how to find the derivative of cosine of x. So now I can actually apply that product rule to find the derivative. So the derivative of y with respect to x is going to be, so the first function times the derivative of the second plus the second times the derivative of the first. In this case, it doesn't matter if I'm talking about the first or second since they're the same. So I get cosine of x times negative sine of x plus cosine of x times negative sine of x. So that's going to end up giving me negative 2 cosine x sine x. Okay, so again, I'm trying to figure out when this function is going to equal 0. So let's set it equal to 0. So 0 equals negative 2 cosine x sine x. So I can use that zero product property where the only way that this is going to equal 0 is if this equals 0, which it never can, this piece equals 0, or this piece equals 0. So where does the cosine function equal 0? So if you go back to our trig days, the cosine function deals with the x values on that unit circle. So if I was looking at this unit circle from 0 all the way to 2 pi, 3 pi over 2, I would have, so the x values are going to be 0 at pi over 2 and at 3 pi over 2. Okay, so I know that this one is pi over 2 and 3 pi over 2. And then where does the sine function equal 0? So sine deals with the y value. So the y values are negative here and here. So that's going to be at within this interval. So it looks like I'm including both 0 and 2 pi. I would say that's going to happen at 0, pi, and at 2 pi, because this is also 2 pi all the way around. So our answer for this would be that the slope of this function has a horizontal tangent at x equals, let's actually write it like this, at x equals pi over 2, 3 pi over 2, 0, pi, and 2 pi on that interval. Let's look at an application that involves trig functions. A particle moves along a coordinate axis in such a way that its position at time t is given by s of t equals 2 times the sine of t minus t for t greater than or equal to 0 and less than or equal to 2 pi. At what times is the particle at rest? So to figure out when the particle is at rest, that just means the particle's not moving, right? So movement, this doesn't say movement. That just says where the particle is in position. But the velocity does say if a particle is moving. If the velocity is 0, that means the speed of that object is 0, which means it's not moving. So I want to figure out when that velocity is going to equal 0. Well, the velocity function can be found by taking the first derivative of the position function. So let's find the first derivative of that position function. So s prime of t equals the derivative with respect to t of 2 sine of t minus t. So that's going to give us the derivative with respect to t of 2 sine of t minus the derivative with respect to t of t. You can pull that 2 out, and the derivative of sine is cosine, and the derivative of t is just 1. So I'm needing to solve where is this function formula, so where is 2 cosine of t minus 1 equal to 0, to figure out when this is going to be at rest, so when it's not moving at all. So let's solve that formula. So I'm going to add 1 to both sides. I get cosine of t equals 1/2. So cosine of t equals 1/2, if I'm looking at that unit circle, okay, I'm trying to figure out those x values that are going to give me a y value of 1/2. Sorry, the angles that give us an x value of 1/2. That's what I'm looking for. Is the angles that give me an x value of 1/2 on the unit circle. Now, if you recall back in our trig days, we learned this chart. Sorry, it should be 0, pi over 3, pi over 6, sorry, pi over 4, pi over 3, and pi over 2. And we've got sine, cosine, and tangent. Okay, so when you fill this out, we get 0, 1/2, root 2 over 2, root 3 over 2, and 1. 1, root 3 over 2, root 2 over 2, 1/2, and 0. 0, root 3 over 3, 1, root 3, and undefined. So what reference angle is the cosine 1/2? And that happens at pi over 3. So that reference angle is going to be here. And then cosine is also negative in this quadrant. So these angles are going to be, because cosine deals with the x's, that's why it's positive in both quad 4 and quad 3. Or, sorry, quad 1 and quad 4. So our angles are going to be pi over 3, and then we've got to figure out what this entire angle is to getting to here. So I know all the way around is 2 pi, or in other words, 6 pi over 3. So if I'm taking pi over 3 away from that, I'd be left with 5 pi over 3. So we can say the particle is at rest at pi over 3. Did not tell us the units, and 5 pi over 3. So at time t, 5 pi over 3 and 5 pi over 3.